Dear learners, welcome to this session. In our journey of learning Python, today we will embark on an important concept of modules and importing of modules. Modules become necessary when we start to build large projects in Python. A module allows you to logically organize your code. Segregating and grouping related code into a module makes the code easier to understand and use. A module is a Python object with arbitrarily named attributes that you can bind and reference. Putting it simply, a module is a file consisting of a Python code. A module can define functions, classes and variables. A module can also include runnable code. The Python code for a module name normally resides in a file named name.py. Here is an example of a simple module, mymodule.py. Let us see the use of the import statement. You can use any Python source file as a module by executing an import statement in some other Python source file. The syntax of the import statement is the keyword import followed by the list of module names module 1, module 2 up to module n. When the interpreter encounters an import statement, it imports the module if the module is present in the search path. A search path is the list of directories that the interpreter searches before importing a module. Now, let us create a simple module called mymodule.py. In this example, you find that we have created a module by the name mymodule.py, and this module has just a single function. In fact, a module can contain much more than that, but for keeping it simple, we have just created only one function in this particular module. The function name is print func and it carries a parameter, and the parameter is a string that you can pass to this function, which the function appends to the keyword to the word hello. So, the job of this function is to print or greet the user whose name is passed on as a parameter to this function with a hello. So, if I send a name to this function, it will say hello and that name. So, this is a simple function that I have created in my module called mymodule.py. Now, to import the module mymodule in the file mymodule.py, you need to put the following command at the top of the script. So, here you see that in this example what we are trying to do is we are trying to import the module. The name of the module what we created earlier is called mymodule, and here we use the keyword import followed by mymodule. Then after that module has been imported, now we can access the method that we have defined, the function what we have defined in mymodule, and that function name is print func. So, that we are trying to access by saying mymodule.print_func, and we are passing a parameter to this module. Here in this case I am passing a parameter ram. So, you see what do you expect when I run this code. So, the function print_function will greet the user whoever name is passed on. So, it may say hello ram, okay, that is what we expect. So, let us run and see. Got it? Yeah. So, you see that it prints out hello ram. In this example, now I have done the same importing of a module called mymodule, but this time what I have done is I have given an alias name. It is also possible to rename a module in our code. For example, in this example we are using import statement mymodule, then we use the keyword as. So, import mymodule as mx. So, what instead of mymodule now the name is mx. So, I have given an alias name. Now, what I can do is now I use the alias name mx to access the function print_func. the same code that what I executed before. Now, when I run this code, what do you expect? The same output, is it not? Let us run and see. Got it? Yeah, same output we have got. Please remember that a module is loaded only once, regardless of the number of times it is imported. This prevents the module execution from happening over and over again if multiple imports occur. Now, we will discuss about importing specific attributes from a module. The Python's from statement lets you import specific attributes from a module into the current namespace. The from import has the syntax as shown. Use the keyword from followed by the module name followed by the import keyword, that follows the name of the modules. So, in total from mod name import name 1, name 2 up to name n. For example, to import the function Fibonacci from the module fib, use the statement from fib import Fibonacci. This statement does not import the entire module fib into the current namespace. It just introduces the item Fibonacci from the module fib into the global symbol table of the importing module. There is another syntax from import asterisk or star statement. It is also possible to import all names from a module into the current namespace by using the import statement this way: keyword from module name import followed by an asterisk or star. This provides an easy way to import all the items from a module into the current namespace. However, this statement should be used with caution. Have you wondered how does the Python interpreter locate the modules you specified in the import statement? Let us see that. When you import a module, the Python interpreter searches for the module in a sequence of steps. It first searches the current directory for the module being imported. If the module is not found in the current directory, Python then searches each directory in the shell variable called Python path. If all else fails, Python checks the default path. On Unix, this default path is normally the root user local library Python, and on Windows it would be the environment variable path. The module search path is stored in the system module sys.path variable. This sys.path variable contains the current directory, Python path and the installation dependent defaults. Let us now see what this Python path variable is all about. The Python path is an environment variable consisting of a list of directories. The syntax of Python path is same as that of the shell variable path. Let us now discuss namespaces and scoping. Variables are names, otherwise called identifiers, that map to objects. A namespace is a dictionary of variable names, what we call keys, and their corresponding objects or values. A Python statement can access variables in a local namespace and in global namespace. If a local and a global variable have the same name, the local variable shadows, that is overrides the global variable. Each function has its own local namespace. Class methods follow the same scoping rule as ordinary functions. Python makes educated guesses on whether variables are local or global. It assumes that any variable assigned a value in a function is local. Therefore, in order to assign a value to a global variable within a function, you must first use the global statement. The statement global followed by the variable name tells Python that the variable name is a global variable. Python stops searching the local namespace for the variables. For example, we define a variable money in the global namespace. Within the function money, we assign money a value. Therefore, Python assumes money as a local variable. However, we access the value of the local variable money before setting it. So, an unbounded local error is the result. The uncommenting of the global statement fixes this problem in the code what we are going to see. In this example, so as I said before, so we are creating a variable called money and we are assigning it to a value 2000 before starting and then followed by another function called add money. Adding money is adding some amount to the variable money. Now, here you see the scope of money is global, okay, and inside the function add money, what I am trying to do is I am trying to add a rupees 100 to this money which is already having a value 2000. So, what do you expect? You expect the value of money to become 2100. Okay. Then we are coming out of the function and we are in the global scope, we are trying to print the value of money. Then we are calling the function add money, then again we are trying to print the value of money. So, what do you expect? Here you expect the value 2000 and here you expect the value 2100, because the add money would have added 100 rupees to the money. But you see, when I run this program, what happens? Oh God, you see, you get an error, what I said before, an unbounded local error. Okay. So, this unbounded local error is due to the fact that we are trying to access the variable money inside a function called add money, and this Python interpreter takes this money variable as a local scope, and therefore, we get this error. So, now what to do? So, as I said, just add this line before that. So, I am going to uncomment this line. So, which is going to add this line, say global money. So, here it reminds the Python interpreter that the money has a scope of global, and now I am going to run the same program again. See, now we got the expected results. Okay. So, 2000 before calling the function and after calling the function 2100 as we expected. Okay. Now, I think you are very clear about the global and the local scope of variables. Now, let us see the dir function. The dir function is a built-in function, returns a sorted list of strings containing the names defined by the module. The list contains the names of all the modules, variables, functions that are defined in a module. Let us do it with an example. In this example, what we are trying to do is we are trying to import a already built in package called math. So, I say import math. So, what do you expect in a math package? All math functions like tangent, cosine, sine, arctangent, log. So, all sorts of math functions. So, all those functions are going to be imported. Okay. Now, we are importing the entire package. Now, what I do? I use the dir function what we have been discussing, and I pass on this math module to this function. Now, I get the content of the math module, which now I am trying to print it out. Now, let us see the result. Yeah, you can see the result. So, you see we have all sets of functions that are listed here. See sine, arc sine h, arctan, arctan2, okay, tan h. So, like that exponential, GCD, log, sine, remainder. So, all sorts of maths functions are actually listed down in the output. So, that means these are the functions that are available in our math module. Got it? So, and this is how you list it out. You list it out using the directory function. Now, what are the globals and the locals function? The globals and the locals function can be used to return the names in the global and the local namespaces depending on the location from where they are called. If locals is called from within a local function, it will return all the names that can be accessed locally from that function. If globals is called from within a function, it will return all the names that can be accessed globally from that function. The return type of both these functions is a dictionary. Therefore, names can be extracted using the keys function. What about the reload function? Remember, I told you in the beginning of this module that when the module is imported into a script, the code in the top level portion of the module is executed only once. Therefore, if you want to re-execute the top level code in a module, you can use the reload function. The reload function imports a previously imported module again. The syntax of the reload function is like this. The reload is a keyword followed by parenthesis wherein you give the name of the module, reload module name. Here the module name is the name of the module you want to reload. For example, to reload hello module, do this, reload hello, that is all. Now, let us turn our attention to another concept called package. A package is a hierarchical directory file structure that defines a single Python application environment that consists of modules and sub packages and sub packages and so on. Suppose we have a directory called phone. Consider a file landline.py available in the phone directory. This file has the line of source code which I am going to discuss in the example. Now, I am going to show you the directory, okay, that we have already I have already created, and I call this directory a phone directory. Okay. So, you can see I have created a directory called phone, okay, and this directory has files called landline and ISDN and G3. So, what is this landline? So, the landline is a Python file. So, when I open that, you see what I get. So, you see that I just try to open this Python file. Now, you see it has a function called landline which simply says I am a landline phone, that is all. It is a simple example. Okay. So, and I have another file called ISDN. So, which again the same thing, but this time it says this ISDN is a function that says prints I am a ISDN phone. Similarly, for this G3 is another type of phone, you can see G3. So, is a definition. So, this says prints I am a G3 phone. Now, all these functions are defined into different modules and they are available in this directory called phone. They are available in the directory called phone. Now, I have another function called underscore init followed by 2 underscores. This function is actually binding all the three modules together. So, you just see what is that I have done here. Here you see, say from landline, okay, import landline, from ISDN import ISDN, from G3 import G3. In fact, actually all these packages contain only one function, but in fact these packages landline, ISDN or G3 can contain any number of functions for that matter, but for keeping things simple I have just put only one function in each. Okay. So, this is what I have done. Now, you want to use this package. Now, what this is, the phone is now a package. Okay. So, this phone is a package which has 3 modules involved in it, the landline, ISDN and the G3. Okay. And all these things can be imported into an example. For example, we are seeing an example here in the, go to the previous directory. Now, here you can see the example. So, just open this example and you see that. Now, when I say import phone, okay, so I automatically import this package. Now, this landline, ISDN and G3. Okay. Now, When you execute this code, now what do you expect? You expect that is going to print out all the 3 lines, I am landline, I am ISDN and I am G3. So, this is what actually happens in this case of a package. In this example we have discussed now, we have taken only a single function in each file, but you can keep multiple functions in your files. You can also define different Python classes in those files, and then you can create your packages out of those classes. We will deal with packages more in detail in another module. Okay. Now that we have come to the end of this module on modules in Python, now let us summarize it. So, in this session we have learnt about what is a module in Python. Then we have seen how to create a module. After having created a module, how do you import a module into another script using the import keyword. We also saw how to rename a module using the as keyword. And we have also seen how to select specific items from a module using the from import syntax. And finally, we have seen about the namespaces, scoping in Python, and also we have seen a small introduction to what is a package. See you in the next session. Thank you.